Okay, so now we're going to look at solving a word problem using systems of linear equations, and this is called problem type 1. So generally that's the more basic problem. So we're going to go ahead and read through this and kind of break down all the information they're giving us. So Amanda does a weekly exercise program consisting of cardiovascular work and weight training. Each week she exercises for at least 12 hours. She spends at most 8 hours doing cardiovascular work. She spends at most 7 hours weight training. Let X denote the time in hours that Amanda spends doing cardiovascular work. Let Y denote the time in hours that she spends on weight training. Shade the region corresponding to all values of X and Y that satisfy these requirements. So there's quite a bit of information going on here. So let's kind of break this down a little bit. So we have cardiovascular work and we have weight training. She exercises at least for 12 hours a week. So I know together, cardiovascular and weight training, which I decided X was cardiovascular and weight training was Y, together they have to be at least 12 hours. So greater than or equal to 12 hours. Okay, so that's the first bit of information they gave us. I know how much she does total. So this is a line that we can definitely graph. Then it tells us she spends at most 8 hours doing cardiovascular work. So X is less than or equal to 8 because it can't, it can't be less than 0. That's another thing. She's not going to work less than 0 hours, but she's not going to go more than 8 hours. So it's at most 8 hours of cardiovascular. And then she's also at most 7 hours of weight training. So that's another less than or equal to 7 in this case. It also can't be less than 0 because she's not going to work out, negative hours. So we have actually 5 limitations here. I have the line for at least 12 hours a week, at most 8 hours for her cardiovascular, at most 7 for her weight training, and then she also can't go below 0 for either one of these. Okay, so let's go ahead and draw all of our lines here. Oh, we're going to turn this into y equals mx plus b really quick, sorry. So I subtracted x from both sides, so that it's y is greater than or equal to mx plus b, so I can graph this line very quickly. So I'm going to start at 12 for this one, and then I'm going to use my slope to go from there. So it's negative, well remember that's a negative 1 if I don't see the number, so it's negative 1, and since it's not a fraction, it's negative 1 over 1. So if I go down 1, I have to go right 1. And I could continue to do that, but I'll go ahead and just draw the line there so that you can see it going down. So now we're going to deal with her limits on cardiovascular and weight training. So for the less than or equal to 8, I'm going to draw a line on 8. So she's not going to go past this point. This is kind of a stopping point here. And then for 7, she's not going to go above this point. Oop, that should be on 7. Darn it, I should have scooted that down a little bit. So I'll have to fix that because that should be right here. So it should be down just a little bit there. So she would also have a limit of 0 and 0, technically the axes, but really they're not going to change anything because it's this section in the middle that meets all the requirements. So it's going to be above this line, greater than this line, but it's going to be before the 8 and less than the 7, which again, I do need to move down a little bit. So it's just this little triangle in the middle here, which would satisfy all the requirements that they gave us. So this is it's what's called an optimization problem, where we have a lot of different requirements going through, and we have to graph all of them to see, which area works for all of these requirements. So I hope that helped, and I will see you on the next video.